Hello, and thank you for joining us for ArcelorMittal's webinar with Automotive Manufacturing Solutions. My name is Gareth Price, and I'm the Assistant Editor of Automotive Manufacturing Solutions magazine. Today, I'm joined by Gagan Tandon and Luciano Maroni, product development experts from ArcelorMittal's Tailored Blanks division. In this webinar, Gagan and Luciano will explore the benefits of combining laser-welded blank technology and solutions with the latest advanced high-strength steel grades, including the new generation of press hardenable steels. Before we start, I'd like to invite all of you to send in questions that Gagan and Luciano will pick up before the Q&A session following the presentation. Just type in the questions to the box in the lower right-hand side of your screen. Also, if you experience any technical issues during this session, please let us know using the Q&A box, and our team will try to fix it. We hope you'll find this webinar stimulating and informative. And with that, I'll now hand over to Gagan to begin the presentation.
Good morning and good afternoon, all. Thank you, Bryce. We thank the AMS organizers for allowing us this opportunity to present. So again, my name is Gagan Tandon. I'm the Director for Product Development from the ArcelorMittal Tailored Blanks in Americas. And together with my colleague in Europe, Luciano Maronini, who is a Manager for Product Development for AMTB Europe, we will present this. So with that, so starting with the agenda, we will walk our audience through who we are as Tailored Blanks in a brief introduction. Then we will talk about the laser welded blanks, the latest steels, the offerings from ArcelorMittal and how that can be combined with laser welded blanks through demonstration of our SN motion-based solution catalog, followed up with some specific highlights on laser welded blanks that we find to be most interesting. And lastly, we'd like to briefly cover the benefits from a stiffness and body rigidity standpoint of laser welded blanks. And with that, we will summarize and then open up for questions. So starting with ArcelorMittal blanks. So we have been in the business making laser welded blanks over the past 25 years. The last 10 years, we have been offering to our customers hot stamp laser welded blanks. We operate currently 26 plants globally and make over 70 million laser welded blanks. We reach out to our automotive customers and worldwide through a number of plants geographically located. As illustrated in this slide, our global footprint includes 10 plants currently in North America, 10 in Europe, 2 in India, and 4 plants in China. All our plants are capable of making cold stamp laser welded blanks, and some of our specific plants are either dedicated or do both cold stamped and hot stamped laser welded blanks. So that is a very brief introduction to who we are, and now I'm going to hand over to my colleague Luciano to introduce laser welded blanks.
Hello everybody, Luciano Marinoni speaking. I'm going to show you what laser welded blank is. It's in fact a part made by 2 or more steel sheets welded together by laser, in which we can combine different thicknesses, different alloys, grades, and different coatings. One important fact to highlight is that the weld seam has a very narrow heat-affected zone. And then the transition between one grade or one thickness to the other is really narrow. And one other important fact is that the evolution of grades, next generation for cold and hot stamping, makes laser welded blank option today more attractive for both cost and weight. And now we are going to show you what is the definition of the tailored blanks. I mean the right materials in the right place. Looking at the advantages more in details about the tailored blanks, normally we start from coils, we nest the part, and we create our blanks. Nesting is one of the main advantages because we use more than 80–85% of the material, according to the design, of course. We laser weld together in order to make the parts. We stamp, and we can stamp cold or hot stamp or stamping both. Another important fact and advantage is the elimination of sub-assembly, because terror blanks is in fact the integration of different parts together in one, and then only one die, only one assembly process, instead of several as the baseline. And finally, terror blanks can permit to have, as I already said, the right thickness where it's really needed, and the right grade where it's really needed, then gauge grade optimization. Then I leave Gagan going on the new steel grades available today.
So let's now focus a little bit on what are the new grades of steels available in our portfolio of solutions to apply for lightweighting today. So as we all know, ArcelorMittal is one of the largest steel suppliers globally, and we have a very large suite of steel grades available, as highlighted in this slide. These are currently available grades that allow the highest level of lightweighting opportunities in the body-in-white structure for the cars. Coupled with that, some of our emerging grades are very, very interesting. Two grades on the cold stamping side are the Fortiform 1180 and the 980, which we will introduce next. And then we will also introduce the Usibor 1000, Usibor 2000, and Ductibor 1000, our second generation of fresh hardenable steels that are now available in the markets. So firstly, the third generation of steels, our first introduction in this portfolio, is the Fortiform HF grades, as we know them, and these are available today in select markets. The Fortiform S grades, which is the high strength, high formability grades, through the QNP process, or the quenching and partitioning process, would be availability details can be shared separately, but from a product design standpoint, both these grades introduce new opportunities for lightweighting. The Fortiform series, HF grade series, allow an additional 10% weight savings potential versus the competing current grades, and the Fortiform S will allow an additional 20% lightweighting opportunity with this product family. So quickly introducing the properties of these materials. As you can see, from a tailored welded blank standpoint, the two properties that we are most interested in cold stamp solutions is the strength, which allows us to lightweight, and the formability through the elongation, which allows us to make more complex formable parts at that high strength level, allowing our customers to down gauge yet meet their performance requirements. So as you can see, these properties for these grades. In terms of footprint and where are these grades available, so this slide illustrates the availability in North America and Europe. Other markets will be developed based on regional demand, and you can see highlighted the different coatings available in combination with these strength levels.
Focusing on hot stamping grades, that today is well known, in which in hot stamping we are today using some grades that after heat treatment, after stamping, are achieving the right mechanical properties. You see in blue, in fact, the current material used, Ductibor 450, Ductibor 500 for energy absorption, and Usibor 1500 for anti-intrusion. The key advantage of the hot stamping is, in fact, the formability, because we stamp at high temperature. The evolution of the PHS grade for, as I already said, absorption of energy and anti-intrusion is shown in the graph. And you see in the new two grades developed by ArcelorMittal, Ductibor 1000 and Usibor 2000, today available and industrialized, that can provide around 15-20% weight reduction on the left hand for the energy absorption, and around 10% weight saving for the anti-intrusion. One important thing is that these new grades have been developed in order to be stamped and to be processed, I mean welded and assembled, by using exactly the same processes today used. There are no changes in the lines. Globally, looking at the availability of these grades, since 15 years, the demand of PHS grades increased vertically. And to cover and to meet customer requirements, in fact, PHS production lines have been extended in all countries, including China and South America, to have a global answer to the requirements. Looking at more in details the product offer, as just said, we saw 15 years ago, a bit more, the first application in automotive of coated steel for hot stamping. After that, the demand increased drastically. And to follow this demand, also new grades have been developed with different mechanical properties that are shown in this specific table. Looking at, not focusing on mechanical properties that are quite easy than different heat strength and UTS levels, we see also elongation and bending angle. Then why there is bending angle here? Then if we see elongation, in fact, we see similar values for several grades. Usibor 1500, Usibor 2000, Ductibor 1000 present similar elongations, but different bending angles. And in fact, the bending angle is what is more linked to what we call crash ductility, or more in detail, the behavior of the grade to absorb energy. And this is in fact the explanation. On the left-hand side, you see the tensile curve of Usibor 1500 and Ductibor 1000 and similar elongation. But it doesn't mean that they present the same energy absorption. On the right-hand side, there is the proof that in the same conditions, the Ductibor 1000 can absorb much more energy than the Usibor 1500. In fact, these two grades are working in different ways. Ductibor 1000 is to absorb energy, Usibor 1500 is to stop. And then looking again in more in details of what we do how we study crash energy absorption, then we see a simple test, an axial test now, that is used for us to do two things in first, mainly. The first is to develop and to provide to the customer all information needed in order to simulate the application and to have a good correlation between simulation and the real test. And second, it's also show that Ductibor 1000 can be well applied in application as front race, rear race, or members, cross members. I leave now Gagan talking about the SE Motion project.
So with this introduction into steel and laser welded blanks, next we will introduce the SN Motion. So SN Motion Steel Solutions is a suite of solutions that ArcelorMittal uses through our R&D and our research. We study virtual car models, and we have developed, as shown in this slide, a number of different car models in virtual reality, where we study the crash and stiffness performances. And through that, we apply the latest and emerging grades of steel solutions. We apply and also evaluate different applications. So laser welded blanks are evaluated using these models, and we will present some of the solutions. So for the purpose of this webinar, we selected two of our most recent studies, the SN Motion Midsize SUV and the SN Motion Midsize Sedan for North America, and similarly from Europe, the SN Motion D segment. And as this slide explains, we create a baseline by benchmarking the best-in-class vehicles in the market, and then from our SN Motion model, we do a full suite of crash and stiffness analysis, incorporating not only the current requirements, but the upcoming requirements, and thereby optimizing the design and producing a number of different application demonstrators for our customers to evaluate in their own designs. In terms of steel grades that were selected and studied, of course, we used all the current grades, and we also evaluated the emerging grades. And the way we present these solutions is we present two types of solution sets, the current grade solutions and then the emerging grade solutions. So the full portfolio of the materials is highlighted here were used in as part of the SN Motion study. So if we look at the mid-size sedan results, 78 kgs of weight savings is possible by application of the first and second generation press hardened steels, and 23 applications of laser welded blanks are highlighted through this study. So we applied both Usibor 1500 and Usibor 2000, as well as Ductibor 500 and Ductibor 1000. Looking specifically to some key parts, and as a quick demonstrator of these, you have some of the parts that we'll talk about in more detail, but here is a quick snapshot. What we want to highlight through this slide is that we don't offer one solution, we offer a suite of solutions for each part. And so you have design options and you have material options, so our customers can evaluate what is the best solution for their specific vehicle and design. So for example, you have a cold stamp solution with emerging grades, you have a hot stamp competing solution, so customers can evaluate. With that, we will then jump to the key focus to this presentation, which is to talk about some of the laser welded blank applications that we found to be very, very interesting. So the first one on the list is the dooring outer solution. So for those who are not fully conversant with the reference of a dooring, dooring represents a way of the side structure. This is the side structure in the vehicle that encompasses the driver's side door, and this dooring is a very, very interesting application for laser welded blanks. Why? This single part allows energy management for a number of competing load cases. This is a single part that helps you through aggressive use of press hardening steels for lightweighting, and it helps improve body stiffness modes. All these are key enablers towards achieving the lightweighting in steel for meeting the CAFE and the fuel economy requirements and the CO2 requirements globally. Honda first presented the Acura MDX at the 2013 Automotive Expo in Nuremberg and highlighted the benefit of the world's first dooring application on the Acura MDX. One of the key benefits, again, by using a laser welded blank and combining these side parts, which were traditionally spot welded together, is to create a continuous load path for the energy management in the structure. And the laser seam, being a continuous joint, allows the seamless transfer of energy from one part to the other during the crash event, and thereby managing the energy pearls, as opposed to doing spot welding, wherein the spot welds have to be the transfer medium between the parts that are joined together. So this really helps both from the energy management standpoint and also helps with the body rigidity modes. Go in a bit more detail into the dooring itself. The one-piece hot stamp dooring allows our customers to tune for a wide variety of crash load cases, starting with the narrow offset, which is a North America only requirement today, and also a variety of different front-end load cases are aided in through the use of the dooring, the side impact, the pole impact, and roof press. These are all very, very critical load cases, and for all of us in body design, these are some of the most challenging load cases, and laser welded blank application through a dooring is a very, very lightweight and performance enhancing way. There is some very strong cost efficiencies that come out of it. So in this slide, we basically talk about the benefit. So firstly, you have one stamping tool as opposed to multiple stamping tools to make all these different parts. You have one stamping operation and for making this whole side structure. There is no post-assembly requirement through spot welding or other assembly means. From the lightweighting concept, what you derive is the combination of different grades. So as we all know, for a majority of our customers today, the side structure has a lot of press hardened steel, and so you can combine the different press hardened steel parts into one part using laser welded blanks. You can optimize the thickness, so you have the right thickness in the right place, and as I mentioned, the no overlap condition through laser welded blanks in a continuous load path. One other benefit is the geometry accuracy. Hot stamping, as we know, produces geometrically more accurate parts because there is virtually no spring back. But in addition, when you use a laser welded blank, you get a very highly geometrically accurate part for the whole side structure, which from an assembly standpoint is very attractive, because it can be then a very important part in setting up the side structure, which then in the end sets the overall geometric tolerance of the vehicle. With the introduction of the second generation of press hardened steels, what we see is now the advantage of not only iterating on the number of weld seams and locations of the seams, but also iterating for the strength combinations. So you can see, as illustrated in the pictures below, that you can combine these different materials together to come up with both grade and gauge combination for the highest level of material utilization for the side structure. To summarize the door rings and one-piece hot stamp door ring, you can see today a number of different variants are possible. We have two applications in mass production today. The Acura MDX since 2013 represents a two-seam laser welded blanks. Honda has communicated at a number of different conferences the benefits, including weight, fit finish, and the energy management to uninterrupted joints. And then starting 2015, we have the Chrysler Pacifica, which has been in production, and this represents the world's most complex door ring in production today, and probably the most complex laser welded blank in production today. It uses 5 pieces welded together as a laser welded blank, and it's the first application of the Ductibor 500. Chrysler spoke about this again at a number of conferences. At the IBC 2016, they presented the 10 kg weight savings that was achieved per vehicle using the application. But we want to highlight really the design flexibility that all our customers can derive in their specific vehicle designs, going from a 2-seam to a 6-seam type of a combination, or a different variant. But essentially, this is truly the key benefit. Now, as we talk about door rings, I want to highlight the fact that door ring is one of the key parts, but not the only part that is optimized to achieve this type of crash safety and vehicle lightweighting. There are a number of parts that come into play, as demonstrated to one of the most challenging load cases of all, which is the small overlap crash. The front rail is very important, the shotgun is very important, and the cross member parts are also very important, as highlighted. Audi recently presented the Audi A8, which uses cross member laser welded blank. The cowl top inner is a very important part in establishing the cross car load transfer. So does the dash panel. And also we would like to highlight the advantage of using laser welded blank on the inner structure, as demonstrated to a roof rail inner, the hinge pillar, integration into the sill, improving what is known as the torque box, load transfer capability, and the B pillar, which Luciano will talk in more detail in some of the upcoming slides. But overall, as you can see, significant weight savings is achievable versus the solution baseline this way. So the shotgun optimization briefly benefits greatly through the application of the advanced high-strength seals. Fortiform 980, 1180 is highlighted in this slide, and this optimization leads to meeting the performance. To end the door ring section, I'm going to take a quick brief pause and present a 30-second video.
ArcelorMittal's 5-piece hot stamped door ring is the most complex laser welded blank in serial production today. This innovative and cost-effective product has assisted the Chrysler Pacifica in achieving significant weight reduction while meeting the most stringent crash performance requirements. The Chrysler Pacifica has won a number of industry acclaims, being the first minivan to receive an IIHS Top Safety Pick Plus award and the 2007 NAIAS Utility Vehicle. We continue to help our customers achieve their goals through our innovative, lightweight solutions.
As well explained by Gagan, we are steel makers, not car makers, but we cannot stop pushing for steel grades only. We have to propose also steel solutions. And this is in fact what we did and we are doing in the SC Motion project. We are studying the market and creating our baseline, and we are working on this baseline, adapting, using our emerging grades and our steel solutions. And focusing on the B pillar specifically, you see in the graph, in fact, the comparison on the main solutions today on the market. And from the left hand to the right hand side, you see a simple laser welded blank in Usibor 1500, Ductibor 500, or more complex solutions with TRB, the tailor rolled blank, then several thickness variations, and soft zone, or the combination of tailor rolled blank and laser welded blank on the bottom in order to have a ductile material to absorb energy on the bottom of the B pillar. And solutions proposed today with emerging grades for hot stamping in Usibor 1500 and Ductibor 1000, or Usibor 2000 and Ductibor 1000. What is important to say is that in this graph, all the applications you see are meeting the same crash behaviors. What we can say now, then, two main points. The first is that sometimes it's not needed to have a lot of thickness variations or different grades in the same applications. And sometimes a simplification of the part can bring the same results. And in fact, you see that the solutions with different thickness variations are at the same level in weight of a simple application as Usibor 1500 and Ductibor 1000, but answering in the same way to a lateral crash in this specific. Another important outcome is that by applying the new grades, the Usibor 2000 and Ductibor 1000, the weight can be improved and optimized, and the cost can be really competitive. By looking to other crash load cases, in this we have the roof crash, we can also make interesting proposals for inner parts, in this case the B pillar inner, and which I will underline the patch. Several times we need patches for both reasons, stiffness and crash. Laser welded blank is well applied and it works well for cost and weight when we integrate some parts together. And this is a good example in which the patch has been integrated in the inner B pillar by modifying just the thickness and maintaining the same grade. This case, in fact, if you see on the bottom, helped to improve the roof crash case. Going on in other cases and looking at the front race, for example, as said already by Gagan, we studied in the SC Motion different solutions, different proposals, cold and hot stamp. Now we selected the main interesting, and in this case you see the hot stamp one. And switching from the baseline made normally by HSLA grades or dual phase to hot stamping, then Usibor 1500 Ductibor 1000, the current generation, on the next generation, the second, then Usibor 2000 and Ductibor 1000, we can save weight around 10 to 20% by maintaining exactly the same performances. Of course, the same proposal can be made in cold stamping to be studied according to the design of the part and the complexity of the part, normal. And looking at other solutions, as for example the rear race, we can see the similar benefits by considering the same concepts. Then In this case, on the baseline, we see three parts. One hot stamped, one cold stamped on the bottom to absorb energy, and one patch added for, again, the both reasons, stiffness and crash. And what could be the laser welded blank solutions? Then in first, integration of the patch by adding a welding line, and in second, the application of the second generation of PHS steel, the Ductibor 1000 and Usibor 2000. In this specific case, in fact, you see that the big patch has been removed and integrated, and more little patches has been added to cover the stiffness and the crash where really needed, then localizing the patches. Moving on and looking at under seat cross members, I would say that this for me is the real example of the application of the laser welded blank. On the left-hand side, we have the baseline. That it's in the market. It's made normally by DP grade 600, 800, in some cases 1000 MPa. These parts have normally other two patches or two parts welded. One linking this part to the seal, and one linking this part to the tunnel. Then now, in this case, we have a hot stamp solution. Why? First, because we need formability, in which the goal is to integrate the two patches in only one part, and to absorb energy on the close to the seal, where it's really needed, by using Ductibor 1000 or 500, and maintaining a lower thickness in the central part using Usibor 1500 or Usibor 2000. This is really the best way to use it. Then tailor blanks can bring weight, of course, because we can use the right material where we want, but also cost if we consider the integration of several parts in one. And then we simplify the process. We have less dive, less stamping operations, and less processes operation, less assembly, welding, and so on. Looking at other applications, for example, the cross members. In this case, you see a rear cross member, but the front, we can say it's quite similar in behavior. This part is important in the other body for stiffness, mainly, and also it's working in some crash load cases. And then in this case, you have in fact two proposals, one called them hot stamping, according to the design, as I already say, in which we have two welding lines in order to have higher thickness on the edges, if needed for stiffness, or on the bottom to increase the strength of the part in case of pressure requirements. In both cases, if we integrate parts and if we localize the thicknesses, we can improve performances, surely, but we can also save weight. In this specific case, studied on our SE motion, it brings around 50% of the weight. And then now, another application, it is the tunnel. Tunnel is the more difficult because it's the core, the earth of the vehicle, in which all stiffnesses and crash requirements are passing through. And normally all tunnels present some patches to improve performances on the upper or on the bottom side. And in Europe is well known, this application, and it could be interesting also in the Americas. We can make two proposals, one with longitudinal welds on the left-hand side, and one with transversal welds on the right-hand side. In both cases, we proposed, and this one is in this specific slide, hot stamped solutions, but why not cold stamped? With the third generation grade, we can anyway improve formability, and we can try to meet the requirements. And as you see, anyway, some patches are needed, but localized and much lighter than the baseline. Then, looking at the front part of the underbody, we have the dash panel. Dash panel is another difficult part for stamping in first, and this part is working again for stiffness because it is linked to all the notch of the vehicle, and also for crash, for the front crash load cases. And now with the new requirements in US and coming also in Europe, the small overlap, this part is becoming really a key part. Focusing on the small overlap crash test, in fact, by maintaining the same thicknesses and the weight is not changing, we can improve drastically. Anyway, we can improve the mechanical, the crash behaviors, just switching from cold to hot stamping, and we can maintain the stiffness where it's needed, thanks to the welding line, and then by combining different grades and materials. Now, and I will spend a few words more on the door. You see historically on the upper part of the slide what we did on doors. Then we studied the baseline, and thanks to the SE Motion in 2010, we studied new solutions, because our goal was to close the gap between the steel door and the aluminum door. Looking at the bottom, in fact, you see some bubbles, and the green one is the target, the aluminum is the lighter, and the orange and the red are the steel doors. What we did now, we applied new concepts of laser welded blank for the inner and new grades for the exposed panels, simplifying a bit the design of the patches in order to close this gap. And in part we succeeded. It's not easy to maintain the same thickness of the aluminum one, of course. But starting from 18 kilos in 2005, we are today close to 12, and not far from the target in aluminum. What is really important to highlight, and we can say that the car is made by compromises between cost and weight every time for every part. In this case, we are today the best compromise because we have a light door in steel, then around 12 kilos, with, in this specific case, less than €1 per kilo save needed. And for the aluminum one is around between 5 to 8, according to the design and the thickness, of course, euro per kilo saved. Then a big gap in cost, and now a less gap for weight. And in details, what we did in the door. Then we applied new grades, Martensite 1500 or Martensite 1200, well known in US and also in Europe, and hot stamping for specific parts as the door beam and the hinges reinforcements. Then what we did, we localized the reinforcements and we changed completely the design of the inner. Normally we were saying inner doors or monolithic or with a vertical line, increasing the thickness and then the stiffness on in the front part of the door. Now we are looking really at the stiffness where is needed. And then in fact you see on the bottom, on the right and bottom part of the slide, you see the design of the inner laser with the blank we would apply on this door in order to save weight. And then I leave Gagan going on with stiffness benefits.
So the last part of our focus is talking about stiffness benefit of laser welded blank. So far we have really highlighted primarily the crash benefits of a number of, or crash performance benefits in a number of these parts. Of course, you know, door is a stiffness component, but even in the body in white. So one of the key things that's happening today is as the automakers continue to lighten the body in white and thinner and thinner gauges of steel panels are used, stiffness is starting to become a key part of the discussion, and recovering the global bending and torsional stiffness and also localized stiffness is important. So what we highlight here is there are applications where laser welded blanks help with stiffness. So one of the examples is the parcel tray or the panel back behind the rear passenger, and applying a laser welded blank in this area is one good way to recover stiffness while continuing to lightweight. The other is rear rail. As we know, rear rail in most car applications is primarily for the crash, but you also have the stiffness requirement for the overall vehicle stiffness, and that's another very important application. And we didn't talk much about body and frame architectures, but we also have solutions that we have studied at great length for body and frame, and here's an example for the how to recover stiffness by using a combination of press hardened steels and advanced high strength steel grades, down gauging, yet recovering through application of laser welded blanks the stiffness. So in summary, I think what we can highlight is the fact that laser welded blanks is a very effective way. Hopefully we have demonstrated through some of these case studies and examples that laser welded blanks are an efficient way to design for both crash and stiffness applications. It's really truly the application, right material in the right place. Our solutions that we have presented here, both in cold stamping and hot stamping, are either in commercial production or would be commercialized. The grades themselves are also either near eminent or already available in the marketplace in different markets, and we continue to strive to work towards helping our customers achieve mass savings. Our S in Motion suite of catalog is one way to demonstrate, but more importantly, we love to work with our customers on adopting our ideas through co-engineering engagements and projects wherein we work hand in hand with our customers in designing. We have a global team of specialists in product development available globally to work with our customers on their specific design requirements and specific product development. For those of you interested in some more videos, since videos are hard to do on a webinar, we have a few links that we will also make available, and we encourage you to watch these videos to learn more about some of the benefits. With that, we will conclude our presentation part of the webinar and open up for Q&A. Thank you.
Thank you, gentlemen. Yes, we'll start looking at questions now, but please do carry on sending them in. The first one we want to take, and perhaps Gagan, this one would be for you. Are the laser welded blank solutions globally available?
Yes, so as I highlighted in our geographic location, we are available to produce locally in 4 different or 3 different continents, but we supply our laser welded blanks worldwide, and all over the world the solutions are available. All the solutions that we have presented would be available worldwide.
And what about future technologies? Is there an alternative to partial ablation?
That's a great question. It's a very specific question relating to our hot stamp laser welded blanks. So for those of our customers who are currently designing with the hot stamp laser welded blanks, we have to do a special process for the aluminum silicon coated laser welded blanks where we remove the coating locally before welding, and that's because the aluminum, if that gets into the weld pool, leads to contamination of the weld seam, and so we don't get recovery of good properties. So with that background, I mean, we developed this process more than 10 years back in being able to remove that coating using a laser. It's a precursor process before we do the laser welding. Now, as part of our research and development, we continue to study alternatives and methods to achieve the same integrity in the finished part without, or with and without. I mean, so we continue to challenge ourselves to innovate, to have the most cost-optimal solutions out there. So yes, we are continuing to study alternative options, and we have presented in some conferences as well some of the things that we are bringing to the market.
Okay, thanks. And actually, Luciano, this is a question for you. What's the advantage of laser welded blanks versus partial hardening?
Yeah, good question. Then partial hardening is well used today in the market, and is a good competitive solution to laser welded blank. I would say there are two advantages. The first is what we can call robustness. I mean, the heat accepted zone in laser welded blank is well controlled and is really narrow and limited to the weld seam. On the other side, in partial hardening, the heat accepted zone is more wide, and during the hot stamping process, it could be maybe less controlled for a massive production. I mean, there is a technical answer also, another explanation that thanks to the next generation grades for hot stamping, I mean Ductibor 1000, laser welded blank can bring a better energy absorption thanks to the new grade, and partial hardening cannot achieve this yield strength and UTS level because it's limited today it's limited because of process to 500 max 700 MPa than in UTS. And this difference can bring roughly, to be calculated part per part, of course, 10% weight reduction on the energy absorption section of the part.
Okay, we also want to know how many weld lines make sense in a laser weld blank?
As I said before, every solution is a compromise between cost and weight, and everything we add in one part has a cost. Of course, a tailor blank with one weld should cost less than one tailor blank with 5 welds. That's sure. We already studied several applications in which both solutions have been compared. I mean, simply solutions with one weld only, or more complex with 5, 10 different thickness variations. At the end, every time the conclusion was that more simpler is the part, better is the process, better is the crash behavior. And in fact, we don't need to have, if I come back to the B-pillar example, we don't need to have 4 or 5 different thicknesses, but one thickness variations is enough, maybe localizing patches if really needed.
Okay, thanks. And Gagan, another question for you. What's the advantage of applying a dooring on EU vehicles?
That's a great question. You know, I've been asked this question because as we highlighted through that presentation, for North America, we have a number of load cases, and the narrow offset is one load case, and in the future, the oblique crash low front end load case are 2 crash load cases that are very North America specific, which the dooring definitely greatly benefits. But as I highlighted through my presentation, the body rigidity is a very, very important consideration that's often overlooked. The way our customers design today, and not to generalize or critique, but I mean, crash is the superseding requirement. Everybody today designs for crash, and then they do their validation for NVH and validation for the overall body rigidity and stiffness, and oftentimes end up adding more parts into the site structure in order to meet the body rigidity modes. And we would challenge our customers in a creative way to, you know, look at that approach and say the dooring is one part that, if designed with the stiffness requirements, you could definitely benefit, and that could be the way forward, or one of the reasons to apply a dooring in a European context, and also even within the other crash load cases, all the other benefits apply for the European designs.
Okay, I think so. We have a couple of product questions actually. The first one, what do you see as the difference between Usibor 1500 and Martensite 1500?
So I'll take that one on. So from a strength level perspective, both these products are in the same strength level. The application, though, is different. So for the Martensite grades, there's no hot stamping process, or traditionally isn't, and the Martensite grades are not press hardenable steel grades. You have the achieved properties as shipped in the material, so all you can do is shape them. That severely limits the ability to make the type of parts you could make. So you could do roll forming, you could make certain type of parts, but with very limited formability. You can mostly at that strength level do bending, flanging, type of things. On the other hand, the Usibor 1500, which is the press hardenable grade, is shipped at a strength level of 690 megapascals. So, our customers transform that into a finished product by the process of hot stamping, as Luciano briefly mentioned. So this opens up the possibility to design all kinds of different shapes and parts through the hot stamping process and achieve. So the final properties of 1500 megapascal is achieved through the hot stamping process, through the heating and quenching process. So, these two products, even though achieve the final strength, the types of parts you can apply them on are very, very different. So they are very, very different classes of steel, basically.
Okay, and another product question goes, are the Ductibor 1000 and Usibor 2000 grades, are they coated steels?
Yes, as you know, part of the coating is for the press hardenable grades is more specific not only to corrosion, but it is to the hot stamping process and what happens to the material when you heat up the material to 900 degrees. So as we know, the uncoated material will scale. You will have surface oxidation, which has to be removed after hot stamping and operation, and that led to the development in the class of steels of the aluminum silicon coated grades. Of course, you could do the zinc coated steels, but the zinc coating has challenges within itself, as has been talked about, and I'm sure the industry is quite aware of. So, which leads to the aluminum silicon coating, and so yes, the Ductibor 1000 and the Usibor 2000 have the same aluminum silicon coating availability as the Usibor 1500 and Ductibor 500.
Okay, I think we've got lots of questions, but perhaps only time to deal with a couple more. And of course, all the questions will be forwarded on to ArcelorMittal. So all of our questioners today will receive a contact in due course. But just for the last couple, could I ask, one of the questioner asks, what's your suggestion about seat tracks profile materials?
So, as we presented, I think seat track, if I understand the question correctly, it's basically the track on which the seat is mounted on. It would be very product specific. We'll have to understand, which specific OEM and what type of an application, what they're currently using, because I'm assuming that the goal here would be to lightweight or improve performance. So I think it's hard to select a particular material without all the specifics, but the Martensite grades could be interesting. The Martensite grades could be interesting because it could be a roll form section. I think that's probably a most common grade today, maybe applied for that. So we would encourage, and we'll obviously follow up with this question with our specific ArcelorMittal contact for this particular answer. So.
Okay, thanks. And I think just one final one to squeeze in. What is the thickness range available in 44 materials which are in supply to the market in India?
So that's a very region-specific question. Unfortunately, we would not be able to answer that question on this webinar, but again, we'll take down the information and we will respond back to the specific person asking the question through our local ArcelorMittal contact for that region. I mean, I could not answer, we could not answer that question at this point. So
Sure.
Good question.
Okay. Yeah, well, in that case, as you say, all the questions will be followed up, but we'll draw it to a close there. Thank you for everyone who did send in a question. The ones we didn't have a chance to answer will be sent on to Gargan and Luciano to follow up. But yes, we'd like to say thank you to Gargan and Luciano for a very informative webinar. As always, the webinar will be uploaded into the AMS archives and accessible for your colleagues who may have been unable to join us for the live presentation. You can access this and all of our previous webinars via the webinar tab at the Automotive Manufacturing Solutions homepage. Look out for the on-demand symbol. We'd like to get your feedback on this webinar, so there is a short survey coming up. Please take the time to complete it. We very much appreciate your input. So thanks again for taking part with us today, and I'll hope you join us again for our next webinar. Thank you. Bye.